Here we're dealing with the cosine of 2 times the inverse trig function. Once again, an inverse trig function is an angle. So we're really dealing with cosine of 2 times an angle. And we've dealt with cosine of 2 times an angle before. Now, this angle is not one we're supposed to have memorized, because it means, if we look at what's just underlined in blue here, tangent of some unknown angle, I'm calling it A, is equal to x, which is x over 1. So I can draw my triangle A, opposite of this x, adjacent is 1. Do the Pythagorean theorem, 1 squared plus x squared equals my hypotenuse squared, and then take my square root, and I get 1 plus x squared. So, remember, when we're dealing with this, we actually have 3 different formulas we could use. Does not make a difference which one you choose. Any one of the 3 will work. I'm choosing the 2 times the cosine of my angle minus 1. So I'll go 2 cosine of my angle squared minus 1. My cosine of my angle is adjacent of 1 over my hypotenuse. If I square the top, I get 1. If I square the bottom, it cancels out the root. So I have 1 over 1 over 1 plus x squared, timesing it by 2 over 1. So I get this when I multiply those 2 fractions together, still with a minus 1. Oh, now I have to do a common denominator, which is 1 plus x squared. So I multiply this one top and bottom by 1 plus x squared. So now I could write it as one fraction. And you have to remember to distribute through your negative sign. So this becomes minus x. So then I get 2 minus 1, which is 1, minus an x squared on top, still over my denominator. Here I want to solve it for x. So I'd have to undo my positive 6. I'd have to undo my timesing by 3. And I'd have to undo my cosine. So to undo that positive 6, I'd subtract 6 on both sides. To undo timesing by negative 3, I'd multiply by negative 1/3 or divide by negative 3. Would not make a difference. Then I'd have to undo my cosine, which would be cosine inverse. And that's how you would get x by itself. Here, we're asked to solve this trig equation over this interval. It's set equal to 0, so we want to try factoring. First step in factoring is greatest common factor, which there is no greatest common factor other than 1, and pulling out 1 is not helpful. Being 4 terms, you want to factor by grouping. What can you pull out of the first 2 terms? Well, I could pull a 6 and a sine squared. That would leave me with a sine and a plus 3. What can I pull out of the last 2? A minus 5. And that would leave me with a sine and a plus 3. So, with that in mind, keeping in mind that both parentheses are the same, so you can pull out your common factor, the x plus 3. What are you left with when you pull out the red? You're left with just this blue, 6x squared with a minus 5. You now have 2 things multiplied together to give you 0, so you can set the first one equal to 0, or set the second one equal to 0. Setting the first one equal to 0, you'd subtract 3 from both sides. And then you'd ask yourself, when is sine equal to negative 3? And you should say, oh, it never is, because sine's always between 1 and negative 1. This one here, you'd have to add 5 to both sides, subtract 6. Divide by 6. Then you'd have to take your square root. Then to get theta by itself, because it's not an angle you're supposed to have memorized, you'd use your calculator. You go inverse sine of square root of 5 over 6, and we would get this. And then you go inverse sine equals the negative square root of 5 over 6, and we would get this. Now, we were just dealing with the inverse sine, which is in quadrants 1 and 4, between negative pi over 2 and positive pi over 2. So we don't have to worry about getting any more answers, because our interval was only over that same interval.